So welcome to the second lesson on electricity, and today we'll be looking at current and potential difference. So our learning intention today is to be able to describe the behaviour of current and potential difference in series and parallel circuits. There's a bit less content to cover today, but you'll be spending a bit more time building circuits with the circuit simulation that we used yesterday. So the success criteria: describe how to measure potential difference and how to measure current. What that means is what pieces of equipment do you use and how do you connect them into a circuit. You should also be able to define the term potential difference and describe the behaviour of current at a junction. Key vocabulary for today is the word ampere, which is the unit of current, ammeter, which is what we use to measure current, battery and cell, which we covered yesterday. Remember, a cell is what is an individual piece, what we would often call a battery in everyday life, and a battery is more than one cell connected in series. The word conserved, particularly important when we discuss the behaviour of current at a junction. Current is conserved. We've talked about the conservation of matter, the conservation of energy in the past, so now we're looking at the conservation of current. The word potential difference, which is also sometimes known as voltage, is measured using a voltmeter, and the unit of potential difference is the volt, which is given the symbol capital V. The challenge task, same as yesterday. I won't go into any more detail than this, but by the end, can you tell me what's the difference between potential difference and energy? So task 2.1 today is to measure current and potential difference in a series circuit. You need to launch the circuit builder that we used yesterday. And when you do that, you can build a circuit. We're going to build a circuit to start with that just has two bulbs in it. So let's and just the one cell. So I'm going to do that. There's my first bulb, my second bulb, a wire between the two. And as we saw yesterday, when we have a complete circuit, all these red dotted circles turn into black dotted circles, and now the current is flowing around the circuit, and I've got equal brightness on the two bulbs. Okay, good. So we're going to look today at using these two components, the voltmeter and the ammeter. So let's get the voltmeter. I'm going to put it onto the middle of the screen, and then I can use these probes to touch the wires, and when I do, I will get a reading on the voltage. I'm going to start by putting the probes either side of the cell. So voltmeters are always connected in parallel to the component you want to measure. You are measuring the voltage or the potential difference across the component. So I've got the two probes either side of the component, in this case the cell, and that's telling me that I've got a voltage or a potential difference of 9 volts. That's the reading on my voltmeter. If I want to read the potential difference across the two bulbs, I connect the probes either side of the two bulbs. If you think about it, the probes are basically still connected in the same place because they're still in the same bit of wire that they were. So actually I'm still taking the same reading really, but you can see that I've got a potential difference across my two bulbs of 9 volts. If I then want to measure the potential difference across the left-hand bulb, I just connect the two probes either side of the left-hand bulb, and I've got 4.5 volts. And if I want to do the right-hand bulb, then I connect the probes either side of the right-hand bulb, and again I've got 4.5 volts. So the total potential difference of 9 volts coming out the cell is being shared between the two bulbs. They're each getting 4.5 volts. Note that's because they're identical bulbs. If the bulbs weren't identical, they wouldn't be sharing it equally, and you get different readings for the two bulbs. But we won't worry about that too much at the moment. To get rid of the voltmeter in this simulation, you just pick it up and drag it back to where it came from, and it disappears. Next thing to try is to measure current, and we're going to use an ammeter. Ammeters measure the current through a component. that means they have to be connected in the circuit so that the current passes through them. Remember, both voltmeters and ammeters don't affect the circuit, they only measure it. So by putting them in, we're not changing any of the characteristics of the circuit. Even though my voltmeter was connected in parallel, it was still a series circuit. And when I connect this ammeter, it's still just going to measure the current in the circuit. I can connect the ammeter in any one place. If I want to measure the current coming out of the cell, I'm going to break the circuit where the cell is and then connect it back up, and you can see I have a current of 0.45 amps. I can break my circuit again and put my ammeter in any number of different places. So let's try putting it in just here. And now if I put it in the circuit just here, you can see again the current is 0.45 amps. Because the ammeter doesn't affect the circuit, I can actually put as many ammeters in as I like. So let's put one in between the two bulbs, and you can see that the current is 0.45 amps. Can you guess what the current is going to be on the other side of the bulb? And hopefully you did. It is 0.45 amps. The current in a series circuit is the same everywhere in that circuit. Regardless of where you put the ammeter or ammeters, they will all show the same reading. The current in a series circuit is the same everywhere in that circuit. So potential difference is shared, the current stays the same for a series circuit. Let's reset, and now we're going to build a parallel circuit. So this time I'm going to have my two bulbs in parallel, and then I'm going to measure the potential difference across them and the current through each of the branches of my circuit. So let's just finish building this. You should have a go, of course, at building all these circuits yourself, because later in the course you're actually going to have to do an experiment, and I'm not going to do it. I'm going to get you to do all the experiment and take all the readings, so make sure you pay careful attention to these. Right, so we're back to our parallel circuit. I'm going to get my voltmeter in to measure the potential difference, and just to check, it is still 9 volts across the cell. If I now measure it across the first bulb, you can see it is again 9 volts, the potential difference is 9 volts, and across the second bulb the potential difference is 9 volts. So this time in a parallel circuit the potential difference is the same across each branch of the circuit. And that kind of makes sense, because if you think about it, this bit of wire and this bit of wire are closely linked. There's no other components in the way, so actually it doesn't matter where on this side I am, I'm effectively on the same bit of wire, and it doesn't matter where on this side I am, I'm effectively on the same bit of wire. If I have both my probes on the same bit of wire, I have a potential difference of 0. There's no difference between these two bits. Right, so the potential difference is the same across each branch. Let's now look at the current. So if I break, I can put my ammeter in to my circuit, and you can see this time I've got a higher current. I've got a current of 1.8 amps. Just going to give myself a bit more room to play with. If I break my branch, I can then measure the current across this branch, and you can see this branch is 0.90 amps. Let's try putting another ammeter in on the bottom branch. And this time, again, it's 0.90 amps. Just to be clear, I can put an ammeter on the other side of the bulb, and you should expect from what we did just now with the series circuit that actually either within that branch the current is the same, it's 0.90 amps. Within this branch the current is the same, 0.90 amps. but out the top it's 1.80 amps. So what we're saying is, and if you look at the electrons you can see it happening, the current splits across each branch, and half of it, because the two bulbs are identical, half of it goes through one branch and half of it goes through the other branch. So what we've got in a parallel circuit is the current is shared. Current is conserved at a junction though, so the same current going in, it comes out. So if I've got 1.8 amps coming in here, I've got 0.9 amps going out of each branch, so that's a total of 1.8 amps coming out. Have a go at building those two circuits yourselves, and have a go at just checking the values. You can perhaps change the value of the resistance on the bulbs and you'll see that the current changes, but still the total current in each branch is adds up to the same as going in. So now our total current is 1.45 amps, and look, 0.90 amps, 0.55 amps. And you can see that whatever I do, these two values add up to this one value. Once you've finished playing around with the circuits, have a go at the knowledge check, make sure that you can answer all of those questions.